Hello student, I am Mr. Varun Kumar, Assistant Professor, Department of Computer Science and Engineering, Ajay Kumar Garg Engineering College, Ghaziabad. And today we are going to start a generating function in recurrence relation, discrete structure theory and logic, KCS 303. First of all, we want to discuss what is the recurrence relation. The recurrence relation for the sequence an is an equation that expresses an in terms of one or more of the previous term of the sequence, namely a naught, a1 up to an minus 1 for all integer n with n greater than equal to 0, while n naught is the non-negative integer. So, a sequence is called a solution of a recurrence relation if in terms satisfy the recurrence relation. In other words, the recurrence relation is like a recursively defined sequence, but without specify any initial value, that is initial condition. Therefore, the sum recurrence relation can have usually as the multiple solution. So, if both the initial condition and recurrence relation are specified, then the sequence is uniquely determined. So, consider the recurrence relation, that is an is equal to twice of n minus 1 and n minus 2 for all values n greater than equal to 2. So, is this sequence is an is equal to an 3n? We check is this particular sequence is an is equal to 3n. So, we substitute an minus 1 is equal to thrice n minus 1. And what is the value of an minus 2? That is 3 n minus 2. We substitute these equations put into this particular equation so that we can get the result that an is equal to 3n. Is there any possible solution is also exist? We consider that an is equal to 5. If an is equal to 5, then what is the value of an minus 1? That is also 5. And what is the an minus 2? That is also 5. So, we substitute an minus 1 is equal to 5 and an minus 1 is equal to 5. Again, we get the an is equal to 5. So, therefore, an with the an is equal to 5 is solution. Also, the solution of this particular recurrence relation to one particular recurrence relation without initial condition can have multiple solution. Modeling with the recurrence relation. Someone deposit 10,000 rupees in saving account and bank give the 5% per year of interest compound annually. How much money will get the account after 30 years? So, we can solve this particular problem with the recurrence relation. So, Pn denoted as the amount of account after n years. How can we determine Pn on the basis of Pn minus 1? So, we can derive the following recurrence relation, that Pn is equal to Pn minus 1 plus 0.05 Pn minus 1. It means this is the principal and this is the interest which is incurred on this particular principal. The total sum is the compound sum, that is 1.05 Pn minus 1. P naught is equal to 10,000. Then we can have that P1 is equal to 1.05 P naught. Then what about the P2? P2 is equal to 1.05 dot P1. And again we substitute the value of P1, that is the also 1.05 square, that P naught. And then again P3 is equal to power 3. Similarly, Pn is equal to 1.05 Pn minus 1 is equal to 1.05 की power n, that P naught. This is the solution. Let us use this formula, find P30, because we want to calculate after 30 years. So, P naught is equal to 10,000. So, P30 is equal to 1.05 raised to the power 30 dot 10,000, that equal to 43,219.42. In general words, we prefer the implicit formula to compute the an rather than the conducted n iteration. So, definition, a linear homogeneous recurrence relation of degree k with constant coefficient is a recurrence relation is form of an is equal to c1 n minus 1 c2 n minus 2 and up to ck n minus k, where c1 c2 and ck are the real numbers and ck cannot be 0. A sequence satisfies such a relation is uniquely determined by the recurrence relation, and k is the initial conditions are given in the numericals. So a naught is equal to c0, a1 is equal to c1 and a2 is equal to c3 and ak minus 1 is equal to ck minus 1. For example, this particular recurrence relation, the Pn is equal to 1.05 dot Pn minus 1 and a linear homogeneous degree 1. This particular recurrence relation, so we check the lowest power of that particular recurrence relation and highest power, calculate the difference between them. The difference between them is 2, so its degree is 2. Then again, then an and an minus 5, the difference is 5, so its particular recurrence relation is degree 5. Solve the recurrence relation using generating function. So we define that what is the generating function. In mathematics, a generating function is a way of encoding an infinite sequence of number, that is an, by treating them as a coefficient of a formal power series. This series is called generating function of a sequence. We assume that the sequence, our sequence is a0, a1, a2, a3 and so on up to infinite, or we can write this particular sequence like this: summation n is equal to 0 to infinite an and x की power n. Or in other terms, we can write this particular generating function as g of x is equal to some coefficient a0 plus a1x plus a2x square plus a3 x की power 3 and up to infinite. So we can remember this particular formula. We use recursively this particular formula for generating function, that is gx is equal to a0 plus a1x plus a2x square plus up to infinite. Then what is the clause formula for generating function? Different type of sequence are generated by the recurrence relation. So we can identify the solution of that particular generating function with the help of the claused formula. We assume that our sequence is ak is equal to 1. So it means if we put k is equal to 0, it means what is the value of a0? What is the value of a0? Put k is equal to 0, that is 1, and a1 is equal to 1, a2 is equal to also 1, a3 is equal to also 1. So this a0 is 1, a1 is 1, a2 is 1 and a3 is 1 and so on. The sequence is 1, 1, 1, 1 up to infinite. So we write this into the summation, that is n is equal to 0 to infinite a n x की power n. So what is the generating function clause formula? That is gx is equal to a0 plus a1x plus a2x square and up to infinite. So we substitute value of each coefficient in this particular equation and we will get the a0 is 1, a1 is 1, a2 is 1 and a3 is also 1. So we check that this particular series is GP. And what is the sum of GP series? That is equal to, if number of terms are infinite, then a upon 1 minus r. A is the initial value and r is the ratio. Okay. So what is the ratio? Ratio is x and initial value, yani initial first term is a, that is 1. So what is the value of this? G of x is equal to 1 upon 1 minus x. If a recurrence relation have ak is equal to 1, then this clause formula is gx is equal to 1 upon 1 minus x. We take second example for clause formula. If our sequence that ak is equal to 2, then what is the value of a0? A0 is 2, a1 is also 2, a2 is equal to also 2, a3 is equal to also 2 and up to infinite. So we write here sequence 2, 2, 2, 2 and up to infinite. So again this is the clause formula, then this is the generating function. We substitute all the coefficient values, a0 is equal to 2, a1 equal to 2, a2 equal to 2 and so on. and if we take 2 common here, then what will we get? 1 plus x square plus x ki power 3 up to infinite, and we solve this particular formula in previous slide, that 1 plus x square plus x ki power 3 that equal to 2 dot 1 upon 1 minus x. So this is the closed formula if our recurrence relation sequence is a to the ak is equal to 2. What will happen if ak is equal to k plus 1? If we substitute k is equal to 0, then we will get 0 plus 1, that become 1. And what is the value of a1? That is 1 plus 1, that become 2, and a2 is equal to 3. So our sequence is 1, 2, 3, 4 and so on. So what is our generating function? That is a naught plus a1 x plus a2 x square plus a3 x ki power 3 up to infinite, and we substitute all the value of coefficient, that is 1 plus 2 dot x plus 3 dot x square plus 4 dot x ki power 3, that up to infinite. We multiply this particular equation, that is equation number 1, by x. So what will happen? That x gx is equal to, if we multiply 1 with x, then that is 1x, then multiply 2x with x, that is 2x square, and 3x is 3x ki power 3 and so on. The infinite number of terms comes in this particular series. So we assume that this is the equation number 2, and we subtract equation number 2 from equation number 1. It means 1 minus 2, that will become gx minus xgx. It means if we subtract that, it means 2 minus 1, then become 1, 3 minus 2 become 1, 4 minus 3 become also 1. That sequence is 1 plus 1 dot x plus 1 dot x square plus 1 dot x ki power cube. This sequence is 1 plus x square plus x ki power 3 plus up to infinite. This is also we have solved in previous slide, that the sum of this particular series is 1 upon 1 minus x. So what is the value of g of x? That this particular 1 minus x reach here. So the solution is gx is equal to 1 upon 1 minus x square ka whole square. What is the clause formula if ak is equal to minus 1 of k? If we substitute k is equal to 0, then minus 1 ki power 0, that become 1. What is the value of a1? That is minus 1 ki power 1, that become minus ka 1. Then what is a2? That is minus 1 ka square, that become 1. It means plus 1 minus 1 plus 1 minus 1, and this is the infinite sequence that is occurs, that 1 and minus 1, 1 and minus 1, 1 and minus 1. So what is the generating function? That is a naught plus a1 x plus a2 x square plus a3 x ki power 3 and so on. We substitute all value of coefficient, that a naught is equal to 1, a1 is equal to minus x, minus 1, then plus 1, then minus 1, and we get this particular sequence. Can we write this particular sequence as this 1 plus minus x ka whole minus x plus minus x ka whole square plus minus x ka whole cube and so on. We consider it as a minus 1. So the formula become that gx is equal to 1 upon 1 plus x. If our recurrence relation solution for this ak is equal to minus 1 ki power k, that is gx is equal to 1 upon 1 plus x. This is a closed formula for recurrence relation if sequence is in terms of minus 1 and minus 1 once and minus 1 up to the infinite. What is the closed formula if ak is equal to k? If ak is equal to k, it means a0 is equal to 0, A1 is equal to 1 and A2 is equal to 2. So we write the sequence 0, 1, 2, 3, 4 and up to infinite. So what is our gx? Gx is equal to a naught plus a1x plus a2x square plus a3x की power 3 up to the infinite. We substitute all the sequence value, that is a naught, a1, a2 and a3. So what will we get? That is 1x, 2x square, 3x square. If we take x common, then what will we get? 1 plus 2x plus 3x square plus 4x की power 3. And in previous example we have solved this particular sequence, then we will get result of this sum of this particular series. So what we will get, that is this sum series is 1 upon 1 minus x का whole square. So the overall our closed formula is x upon 1 minus x का whole square. If our sequence is AK is equal to k, then we will get the generating function gx is equal to x upon 1 minus x का whole square. What will happen if our sequence is 0, 0, 1, 1, 1 and 1 up to the infinite? Initial two terms are 0. Then what will happen? Then we substitute value of a naught and a1 as 0 and remaining coefficients are 1. Then 0 plus 0 dot x plus 1 x square plus 1 x की power 3. And we know that ki 1 plus x square plus x की power 3 up to the infinite. We have the formula for this particular series. So we add something here, we add 1 and x, 1 plus x, and we subtract minus 1 and minus x here. So what will happen that? Then this will comes as a x square divided by 1 minus x square. What will happen if our sequence is 1, 1, 0, 1, 1? Then any particular sequence, that is A2, A3 or A4, whatever may be the value of coefficient, that particular coefficient value is just the value of 0, then what will happen? Then 0x square. So we can write this particular function as we add here 1 dot x square and subtract 1 dot x square. So this particular series have the formula of generating closed formula, that is 1 upon 1 minus x, and remaining, that is minus x square, is terms here. Then what will happen if sequence is 1, 0, minus 1, 0, 1, alternate zeros and alternate 1 and minus 1. Then a naught, what is the value of a naught? That is 1. What is the value of a1? That is 0. What is the value of a2? That is minus 1. So we substitute all the values. Then what will we get? That is 1 minus x square. This term is 0. This term is comes. This term is 0. This term is comes. And it means alternate terms are comes. 1 x square, x की power 4, x की power 6, x की power 8, x की power 10 and so on. And first term is 1, then minus 1, 1, minus 1, plus, minus, plus, minus, plus, minus, plus, minus. This is the infinite series. So we can write in this particular terms that 1 plus minus x ka square, then plus minus x square ka whole square, that become plus minus x square multiplied by minus x square, that is equal to plus x की power 4. So all terms are comes. Then what is the closed formula? That is 1 upon 1 minus x ka whole square, or we can multiply the minus in inside. Then what will we get? That gx is equal to 1 upon 1 plus x square. So we have calculated here that if our if our sequence is 1, then we will get the 1 divided by 1 minus x. If we have the sequence minus 1 की power k, then we get the result 1 upon 1 plus x. If a n is equal to any coefficient, then we will get then coefficient divided by 1 minus x. if k plus 1, then we will get 1 upon 1 minus x ka whole square. We remember this particular clause formula for solving the recurrence relation using generating function. Then again, if ak is equal to k, then we will get x upon 1 minus x square. If we have a ki power k, then we will get 1 upon 1 minus ax. If we have a ki minus a ki power k, then we will get 1 upon 1 plus ax. If we have k square, then we will get x dot x 1 plus x divided by 1 minus x cube whole cube. And if k dot a ki power k, then we will get ax divided by 1 minus x square. Now, we have to use some generating formulas for to solve these following questions. We take one by one. What will happen if an is equal to 3? It means an is equal to any coefficient, that is coefficient, it means c. So, what is the formula if ak is equal to c? So, formula number 3, if an is equal to c, then we use this particular formula, that c upon 1 minus x. So, what is the solution of this particular recurrence relation? That is, we can say that g of n or g of x is equal to some coefficient, that is c upon 1 minus x, that become 3 upon 1 minus x. We take second numerical, that is an is equal to n plus 3. So, we divide this particular function into two parts, that is n and 3. For n, it means what we will use, that k. Formula number 5, if ak is equal to k, if ak is equal to k, then solution is x upon 1 minus x ka whole square. So, we use this particular formula over here, that if ak is equal to k, then what is the solution? What is the solution? That is, if kk, then x upon 1 minus x ka whole square. It means we use that x upon 1 minus x ka whole square. Or what is the solution for some coefficient 3, that is 3 upon 1 minus x. We take a next example, that if an is equal to 3 ki power n, what is the solution for clause formula for this particular series, that is a ki power k. Then the generating function that we can use this particular slide, that is a ki power k, then solution is 1 upon 1 minus a of x. So, what is the value of g of x? That is 1 upon 1 minus 3 of x. So, we can solve easily the recurrence relation if recurrence relation is directly given in the clause formula. We take an example that we are recurrence relation AR minus twice of AR minus 1 minus 3, AR minus 2 that equal to 0 with initial condition A naught is equal to 3 and A1 is equal to 1. So, how we solve this particular recurrence relation using generating function? So, step 1 suggests that we use the step 1, we multiply this particular equation with x to the power n, and we take summation of this particular all the terms, that is summation n r is equal to 0 to n is equal to 2 to infinite, then a of r dot x ki power r, then minus summation r is equal to 2 to infinite, then a r minus 2 dot x ki power r, minus summation r is equal to twice to infinite, that is 3 dot a r minus 2 dot x ki power r, that equal to 0. Why we take the initial condition r is equal to 2? Because the degree of this particular recurrence relation is 2. The highest power and lowest power difference between them is 2 only. So we write here the summation r is equal to 2 to infinite, and we multiply this particular whole equation with the x की power r. So step 1 is clear. Then we expand all the formulas here, that if we substitute r is equal to 2 here, so what will we get? Then a2 x square plus a3 x की power 3 and plus a4 x की power 4 and so on. So this is the solution for this. What is the expansion of this? We take minus 2 as a common, and if we substitute r is equal to 2, then what will we get? That is a1 then x square, a1 x square. If we substitute r is equal to 2 here, then what will we get? a1 and x square. If what is the next value of r? That is 3. If we substitute r is equal to 3, then what will we get? That is a2 dot x की power 3 and so on. And what about this? That is minus 3 is common, and if we substitute r is equal to 2 here, then what will we get? That is a naught x की power, then substitute 2, that is square, plus a1 x की power 3 plus up to infinite, that is equal to 0. So we solve these following terms. We know that our generating function, that gx is equal to a naught plus a1x plus a2x square and so on. So we must know that a naught x square, the following terms are already covered. The following terms are already covered in this particular equation. So we can write this, take this side, then what will we get? That g of x minus a naught minus a1 of x. So we substitute this particular equation. Then what is here? If we compare this particular equation with this particular equation, so what is the coefficient of this particular x? Is a1. So we take x is common here. So what will we get? Minus 2 of x, then a1x plus a2x square up to infinite. It means this particular terms comes, so this might be minus twice of x, g of x, that minus a naught. And what about the third term? That is this, that a naught x square, we take x square as a common, so minus 3x square a naught plus a1x plus and up to infinite. So this is the formula for g of x minus 3x square and g of x. We substitute all three values in this particular equation, and what will we get? What will we get? That is gx minus a naught, gx minus a naught minus a1x minus twice of x, that gx minus a naught and minus 3x square g of x is equal to 0. Our initial condition is a naught is equal to 3 and a1 is equal to 1. We substitute our initial condition and multiply by them, then gx minus a naught is 3 and a1 is 1. So minus 2x g of x and minus 3 minus 3x square g of x is equal to 0. So we take gx as a common, then what will we get? That is 1 minus twice of x minus 3x square, and remaining terms from equal to sides. Then what will we get? We get minus 3 minus 5x. So g of x is equal to 3 minus 5x, that divide by 1 minus twice x minus 3x square. We can divide this particular equation in two parts, that is equal to 3 minus 5x divide by 1 minus 1 plus x and dot 1 minus 3x. So using partial fraction, we can say that g of x is equal to a divided by 1 plus x and plus b 1 minus 3x. After solving the recurrence, this particular partial fraction, so we will get the some values of coefficient. The value of coefficient, that is equal to a is equal to 2 and b is equal to 1. So what will we get? That is 2 upon 1 plus x, that plus 1 upon 1 minus 3x. So we convert this particular generating formula, explicit set formula, into the a of n. So what is the value of a of r? This is the particular formula where 2 is the coefficient. So we can write this 2 into 1 minus 1 की power r, and what is this formula for? 1 dot 3 की power r. Using the closed formula of this particular situation, then we can say that a to the power k, that is equal to 1 upon 1 minus a k, and we use one more formula, that is for minus 1 is equal to this 1 plus x. So this is the method to how to solve this particular recurrence relation. So we can revise that particular question. You write a recurrence formula, multiply by x की power n and take summation, and take summation. Initial condition is comes from with the degree, that is the lowest power and highest power, difference between lowest power and highest power. So we write that r is equal to 2 to infinite, that a r dot x की power n, expand this series and convert this into the g of x. Then after substitute, take gx is common and other things are aside, and what is the formula of gx? This. Then after that, the partial fraction, the calculation of the partial fraction coefficients, and then we use the closed formula and convert that particular into the solution domain, that is a of r is equal to twice dot minus 1 की power r plus 1 dot 3 की power r. Okay, thank you.